Okay, let's see how to solve trigonometric equations. Example 23. Solve the following equations for angle theta between 0 to 360 degrees. Question A, sine theta equals to negative 0.5446. So in this case, the first thing is we have to find the reference angle alpha. So alpha is equals to shift sine 0.5446. So in order to find the reference angle alpha, okay, we just ignore the negative sign in 0.5446. Shift sine 0.5446 equals to 32.997. So if you round off this value correct to 2 decimal places, then the value is going to be 33.00. So we can just write as 33 degrees. Okay, next, sine is negative in quadrant number 3 and 4. So sine theta negative in quadrant 3 and quadrant 4. For quadrant 3, theta is equals to 180 plus alpha, whereas in quadrant 4, theta is equals to 360 degrees minus alpha. So in this case, theta is equals to 180 plus 33 and 360 degrees minus 33, and the value of theta is equals to 313 degrees and 327 degrees. Okay. Let's look at question B. Cos 2 theta equals to 0.3420. The first thing is we're going to find the reference angle alpha. Alpha is equals to shift cos 0.3420, shift cos 0.3420. Okay, if you round out the value correct to 2 decimal places, then we will get 70 degrees. Cos theta is positive in quadrant 1 and quadrant 4. Okay, in quadrant 1, theta is equals to alpha, and in quadrant 4, theta is equals to 360 minus alpha. Okay, so in this case, 2 theta itself is going to be theta in this formula. Okay, therefore 2 theta is equals to 70. Okay, this is for the first quadrant. 2 theta is equals to 360 degrees minus 70. Okay, and if you solve this, then theta is equals to 70 divided by 2, which is 35, and here theta is equals to 360 minus 70, 290 divided by 2 is equals to 145. Okay, normally when cos 2 theta, you're going to have 4 answers. Okay, theta is equals to 35, under 45, 35 plus with under 80, 215 degrees, and then under 45 we add under 80, we will get 325. Okay. So why we need to add under 80? Okay, so before that, why is under 80? Okay, it's under 80 because 2 theta is equals to 360 degrees. Okay, because the graph cos 2 theta will have 2 cycles within 360 degrees. Okay, so the period is going to be 360 divided by 2, which is under 80 degrees. Okay, so if you sketch a cosine graph, the graph is going to be something like this. 1 cycle, okay, and 2 cycles. Okay, so this is 360 degrees under 80, 0, 1 is here, okay, and negative 1 is here. We have 0.3420 here. Okay. There will be 1, 2, 3, 4, 4 solutions. Okay, so earlier, okay, we get 35, and the value here is under 45. Okay, so the distance from the first solution to the third solution is actually under 80 degrees. Since the period is under 80 degrees, so the graph will repeat after every under 80 degrees. Okay, and okay, here is point number 2, and here is point number 4. Okay, so the distance between solution number 2 and solution number 4 is also under 80 degrees. Okay, so that's why we add under 80 degrees for first solution in order to get solution number 3, and we add under 80 to solution number 2 in order to get solution number 4. So let's say it's 3 theta, then you're going to get, okay, 6 solutions. Okay, 6 solutions, and the value that you're going to add, it should be 3 theta equals to 360, and theta is going to be under 20. Okay, let's look at example 28. Okay, solve the equation 3 sine a plus pi over 3 equals to 0.99 with the condition a between 0 to pi radian. 3 sine a plus pi over 3 equals to 0.99. So I'm going to divide this whole equation with 3. So we'll get sine a plus pi over 3 equals to 0.33. Okay, so by assuming a plus pi over 3 as theta, okay, so the first thing is we have to find what is alpha. Okay, as usual, alpha is equals to shift sine 0.33, and the value is equals to, before we proceed, let's change the mode of the calculator to radian. Shift menu, we choose angle unit, choose radian. Okay, now we can press shift sine 0.33. okay, and the answer is 0.3363. 0.3363 radian. Okay, we write the answer correct to 4 decimal places. So based on the equation that we get here, sine is positive. So sine theta is positive in quadrant number 1 and quadrant number 2. For quadrant number 1, the formula to calculate theta is theta equals to alpha, and for quadrant number 2, theta is basically under 80, okay, minus alpha. But since the angles are in radian, we have to change this under 80 degrees to pi. So earlier I already explained the value of theta in this case is a plus pi over 3. So we're going to apply, okay, theta and the value of alpha into these two formulas. Okay. The first one, theta is equals to alpha. So theta is a plus pi over 3 and it's equals to 0.3363. Okay, so now a is equals to 0.3363 minus pi over 3. Let's use the calculator. 0.3363 minus pi over 3. Yeah? So the value of pi that I'm going to use here is 3.142 divided by 3. And I get negative 0.7110. Negative 0.7110. Okay, next, okay, to find the value of theta in the second quadrant, I'm going to substitute theta with again a plus pi over 3 and pi equals to pi minus alpha, which is 0.3363. Okay, so let's solve this. A is equals to I'm going to use 3.142 for pi. So 3.142 minus 0.3363 minus 3.142 divided by 3. And here I get 1.758. 1.758 radian. And if you refer to the range of the value of a must be between 0 to pi radian. So therefore, we reject this value. Okay, a cannot be negative value. Hence, a equals to 1.758 radian. Okay, let's look at example 29. Find the values of x that range from 0 to 360 degrees that satisfy the following equations. A sine 2x plus cos x equals to 0. So since we have sine 2x, we need to use double angle formula. We know that sine 2a is equals to 2 sine a cos a. So in this case, we can replace the a with x. So sine 2x plus cos x equals to 0. So I'm going to substitute sine 2x with 2 sine x cos x, and then plus with cos x equals to 0. And in this case we can factorize the cos x. So cos x bracket multiply with 2 sine x plus 1 equals to 0. And now we can write this as cos x, okay, equals to 0, or 2 sine x plus 1 equals to 0. So when cos x equals to 0, from our knowledge, okay, related to the cosine graph, we get to know that x is equals to 90 and 270 degrees. And now let's see how to solve, okay, 2 sine x plus 1 equals to 0. So first of all, 2 sine x equals to -1, sine x equals to -1/2. Okay, so first we have to find the value of alpha, which is the reference angle. Alpha is equals to shift sine 1/2. So this is actually related to special angle, which is 30 degrees. And we know that sine is negative in quadrant number 3 and quadrant number 4. Okay, for quadrant number 3, theta is equals to 180 plus alpha, and for quadrant number 4, theta is equals to 360 degrees minus alpha. Okay, now let's find the value of x. So x is actually equivalent to theta. So for quadrant number 3, x equals to 180 plus 30. So we get 210 degrees. And for x in fourth quadrant, x is equals to 360 degrees minus 30, and the value of x is 330 degrees. And finally we can combine all the solutions. X equals to 90, 210, 270 and 330. Okay, let's look at question B. 2 cos 2x minus 13 sine x plus 10 equals to 0. Okay, and once again we're going to use double angle formula, and the double angle formula that we're going to use here is actually related with cos. Since we have sine x in this formula, the double angle formula that we're going to use here should be cos 2a equals to 1 minus 2 sine square a. So 2, okay, cos 2x, I'm going to substitute with 1 minus 2 sine square x minus 13 sine x plus 10 equals to 0. So let's expand and simplify this equation. 2 minus 4 sine square x minus 13 sine x plus 10 equals to 0. And if you simplify this, you get negative 4 sine square x minus 13 sine x plus 12 equals to 0. Okay, I'm going to divide this whole equation with -1 so that it will be easier for us to do the factorization. 4 sine square x plus 13 sine x minus 12 equals to 0. So we assume a as sine x, then you will get 4a square, okay, plus 13a minus 12 equals to 0. Okay, so this is a quadratic equation, and now we can factorize this quadratic equation. So 4a minus 3, a plus 4 equals to 0. Okay, and in fact we can verify this using the calculator. Okay, the value of a is 4, b is 13, c is negative 12. Okay, so we get 3 over 4. So when you put inside the bracket, it becomes negative 3, and over 4 you bring it in front of the a. And next, minus 4, so inside the bracket it becomes plus 4. Now I'm going to replace the a with sine x. 4 sine x minus 3 sine x plus 4 equals to 0. Okay, and so when you multiply this you get 0. So either one of these must be 0. So it can be either 4 sine x minus 3 equals to 0, or sine x plus 4 equals to 0. And if you solve this, you get sine x equals to 3 over 4, and sine x equals to negative 4. Okay, so if you still remember, these are the two solutions that we get from our calculator, 3 over 4 and negative 4. For sine and cosine, the range of the values must be negative 1 to 1. Okay, so in this case negative 4 already exceeded the range, so therefore there is no solution for this part. Okay, and as usual, let's find alpha. Alpha is equals to shape sine 3 over 4 and the value of the reference angle, shape sine. Okay, and don't forget to change the mode of the calculator to degree. Okay, so shape sine 3 over 4, and the answer is 48.59. 48.59 degrees, and sine is positive, so the solution for x is in the first and second quadrant. So x is equals to, okay, theta is equals to alpha, so therefore we get 48.59, and for the second quadrant is 180 minus alpha, so 180 minus 48.59 is equals to 180 minus 48.59. Okay, the answer is 131.41.